Assalamualaikum warahmatullahi wabarakatuh. So the first topic in the final coverage is the applications on derivatives. Ibig sabihin nun, eto na yung application doon sa previous lesson natin na derivatives of a function. Here, we will talk about first the maximum or the minimum values of a function. A function f is said to have a relative maximum value at x sub o. The value is f of x sub o if there exists an open interval I containing the x sub o on which f is defined and that f of x sub o is greater than or equal to f of x for all x in this interval. So, kaya nga siya greater than because ang function f doon natin dito is said to have a relative maximum, which means greater than. Okay, it has a relative minimum naman, a relative minimum value at x sub o. The value is f of x sub o if there exists an open interval I containing x sub o in which f is defined and that f of x sub o is less than. Okay, less than f of x for all x in this interval. So that's why relative minimum because less than yung f of x sub o natin sa function natin na f of x. If a function has either a relative maximum or a relative minimum value at x sub o, then f is said to have a relative extremum. So, for instance, class, may function tayo na f and then masasabi natin na yung function na yun is is said to have a relative extremum at the point x sub o if the given function has either a relative maximum or relative minimum. So, possible din class na yung function natin is wala siyang relative max, meron siyang relative mean, or meron siyang relative max, wala siyang relative max pero meron siyang relative minimum. If the first theorem here, class, is if f of x exists for all values of x in the open interval a, b, and if f has a relative extremum at x sub o, where x sub o is between the interval a to b, and if f prime of x sub o or the first derivative exists, then f prime of x sub o equals to 0. So, kung yung function natin na f of x class is mag-exist siya for all values of x in the given open interval, and then that function has a relative maximum, which means may relative max siya at saka may relative minimum din siya at the point x sub o. Then, yung first derivative ng function na yun is equal to 0. If x sub o is a number in the domain of the function f, and if either f prime of x sub o equals to 0 or f prime of x sub o does not exist, okay, pwede rin na yung function ng, yung value ng, yung derivative ng function natin class is pwede hindi din siya mag-exist yung derivative niya. Then x sub o is called a critical number or a critical value of f. A critical point is a point x sub o and f of x sub o on the function f corresponding to the critical number at x sub o.
Values and critical points of each of the following functions. So for example, ang given natin na function class is y is equal to f of x is equal to 3x squared minus 3 over 4x to the power of 4. Para makuha natin si critical values and critical points is kailangan natin kunin yung first derivative nito. So, the derivative of this given function is magiging 6x minus 3 over 4 times 4 kasi 'di ba ibababa natin yung exponent. So 3 over 4 times 4 x to the power of 3. So we have 6x is equal to, this one is cancel out na yan, so we left with 3x to the power of 3. So eto yung first derivative niya. And then after ninyong makuha yung first derivative niya class is i-equate ninyo sa 0 si first derivative. Ibig sabihin etong na-obtain na din na first derivative is i-equate natin siya into 0. And then, after natin siyang ma-equate into 0 class, is, okay, after natin siyang ma-equate into 0, ifa-factor natin siya. So, we have 6x minus 3x cubed equals to 0. Ito siya galing doon sa first derivative na na-obtain natin sa given na function. So, since ito, pwede natin siyang ma-factor as 3x times 2 minus x squared kasi 'di ba their greatest common factor is 3x, right? Okay, so factors of 6 is 3 and 2. So, pwede nating ilabas si 3 and then x is also the factor of, the greatest common factor of 6x and 3x cubed. Okay, so we factor out 3x, so we left here with 2 na lang. And then dito sa second term is x squared. Okay, and then after that, find the values of x. And then pag nakuha natin yung values ng x, yun yung magiging critical values natin or critical. And then, para makuha natin yung critical points niya, yung nakuha natin na critical values is isa-substitute natin dito sa original na function. Okay. So, equate natin to sa 0. So, 3x is equal to 0 and also 2 minus x squared equate to 0. So, solve for x. We have x is equal to 0 because we divide it both sides by 3. So, 0 divided by 3 is 0 pa rin. Then, eto naman, transpose natin dito si x squared. So, we have to get the value of x, squaring it both sides. So, we have x. Okay, parehas lang to ha. Dito ko lang nilagay si x. So, cancel out na to. Cancel out na din yan. So, we left with x is equal to, pag nag-square tayo both side, we have plus and minus, and then square root of 2. So, therefore, the critical values are 0, 2, and the negative 2. Kasi ito, di ba dalawa ito? X here is equal to positive square root of 2, and x is equal to negative square root of 2. So, all in all, ang critical values natin is 0, square root of 2, and negative square root of 2. To get the critical points, etong nakuha natin na critical values class, substitute nyo lang dito sa original na function. And then yung mangyayari is point. Ibig sabihin partner. So kung si for instance si 0, okay, so pa i-substitute natin dito si 0, magiging 0, 0 na to. So ibig sabihin, the first critical point is 0, 0. Okay, CP is critical point, stands for critical points. And then, it follows also si square root of 2. Okay, so square root of 2. And then, para makuha ninyo yung ilalagay nyo dito, substitute nyo lang dito sa original na function. And then, kung tatlo yung critical values, it follows also na tatlo din yung critical points. When we say critical points, that is an ordered pair. We have x and y. Okay, so next example is, ang given na function is x cubed minus 3 over 2, x squared minus 6x. Okay, so the first step is get the derivative. So, ang derivative ni x cubed is 3x squared. Derivative nito is 3 over 2 times 2 times x, and then derivative ni 6x is 6. So, simplify natin siya. So, we have 3x squared. So, we have 3x na lang minus 6. And then, after ninyong makuha yung derivative niya, equate ninyo sa 0. So, we have f prime of x is equal to 0. Okay, so ang nakuha natin na first derivative is ito. So, bring down here and then equate natin sa 0. And then, after that, factor natin siya para makuha natin yung values ni x. Okay, so factor out natin si 3 because 3 is their greatest common factor. So, we left with the x squared here. Here naman is x na lang. And then, sa last term is 2. So, ang factors ni x squared minus x minus 2 is x minus 2 times x minus 1 equals to 0. So, lahat natin to i-equate sa 0. Si 3, equate sa 0. Si x minus 2, equate sa 0. Si x minus 1, equate din natin siya sa 0. So, since 3 is not equal to 0, so which means this is false, and then it implies that it is rejected kasi hindi man siya nag-true statement. Okay, so this is rejected ha, pag hindi sila equal. Okay, and then, eto, transpose natin doon si 2. So, we have x is equal to 2. And then, x minus 1, transpose si 1 sa kabilang side. So, we have x is equal to 1. It implies that the critical values of this given function is 2 and 1. Okay? 2 and 1, yan yung values na nakuha natin na values ni x. And then, to get the critical points, si 2, substitute nyo lang dito. And then, yung makuha nyo na value ni y, yun yung partner ni 2. The same with 1, substitute nyo lang dito. And then, yung makuha ninyo na value ni y is yun din yung partner ni 1. So, ibig sabihin, yun yung critical points niya.
The function f is said to have an absolute maximum value on an interval if there is some number x sub o in the interval such that f of x sub o is greater than f of x for all x in this interval. So in such a case, f of x sub o is the absolute maximum value of f on the interval. The function f is said to have an absolute minimum value naman on an interval if there is some number x sub o in the interval such that less than si f of x sub o sa f of x natin. So, parehas ng concept doon sa relative maximum and relative minimum. F of x sub o is greater than or equal to f of x, ibig sabihin relative max or absolute maximum value. And then, if f of x sub o naman is less than or equal to f of x, which means parehas lang din as relative minimum or the absolute minimum value of on an interval. Okay, the value of f of x sub o is the absolute minimum value of f on interval. So, an absolute extremum, meron din tayong na-mention kanina na relative extremum. Dito, an absolute extremum of a function on an interval is either an absolute maximum value or an absolute value of the on that interval, of the function in that interval. So, we have remark here, a relative max or relative minimum value of f is not necessarily the absolute maximum or absolute minimum value of f. So please take note of that. Hindi necessary na si relative max or relative minimum is yun din yung absolute max or absolute minimum. Though, parehas lang sila ng definition.
Next theorem is the extreme value theorem. If a function f is continuous in the closed interval ab, then f has an absolute maximum value and an absolute minimum value on ab. So we have steps or 3 steps on finding the absolute extrema. Okay, the first step is find the function values at the critical numbers of f on AB. Ibig sabihin nun, yung na-discuss na natin kanina na paano hanapin sa critical numbers, just get the derivative of the given function and then i-equate natin siya sa 0 and then find the values of x and then yung nakuha natin na values ng x doon, yun na yung critical numbers natin. And then find the values of f of a and f of b, where a here is on the given interval and then b is on the given interval also. Ibig sabihin, kung ano yung given na interval is, kung ano yung nauna is yun yung A and then yung pangalawa naman is yun yung B. The largest of the values obtained in step 1 and step 2 is the absolute maximum value of f, and then the smallest of the values obtained in the absolute minimum value of f is the absolute minimum. Ibig sabihin nun, i-compare natin yung result na makukuha natin kay number 1 and number 2, and then yung pinaka-largest doon is siya si absolute max, and then yung pinaka-smallest naman is yun yung magiging absolute minimum value natin. Okay, for example, given the function f of x is equal to x cubed plus x cubed plus x squared minus x plus 1, find the absolute extrema of f on the given interval. Okay, on the given interval, -2 and 1/2. Okay, so here is our solution on that given example. So, ang given natin na function class is f of x is equal to x cubed plus x squared plus minus x plus 1. And then, yung given natin na interval is -2 and 1/2. So, ibig sabihin nun, ito yung A natin and this one is our B. Okay, so the first step is find the function values at the critical number. So, ibig sabihin, derive natin to. Then, after that, equate natin sa 0. So, ang derivative ni x cubed plus x squared minus x plus 1 is 3x squared plus 2x minus 1. Okay, so ito yung derivative niya. And then, equate natin to sa 0. So, we have 3x squared plus 2x minus 1 equals to 0. And then, ang factors nito class is si 3x minus 1 and si x plus 1. Okay, so I hope na may idea na kayo kung paano mag-factor ng given equation. Okay, so after that, after natin siyang ma-factor, equate natin lahat ng factors niya into 0. So, we have 3x minus 1 equate to 0. X plus 1 equals to 0 din. Then, solve for the value of x. So, we have 3x. Transpose natin si 1 dito. So, that's why naging positive. To get the value of x, just divide by both sides by 3. So, we have x is equal to 1/3. And then, the other one is transpose lang natin si positive 1, magiging negative 1. So, it implies that this is our critical values. Okay. So, tapos na tayo sa step 1. So, let's proceed to the step 2. Sa step 2, find the values of f of a and f of b. Di ba ang given natin na interval is negative 2 and 1 half? So, ang a natin dito is negative 2 and then b is 1 half. So, ibig sabihin nun, eto siya, i-substitute lang natin siya doon sa given natin na original na function. So, we have f of negative 2. Simply replace all the variables x here by negative 2. So, magiging negative 2 raised to the power of 3 kasi diba x cubed ito plus the negative 2 squared minus the negative of 2 plus 1. So, we have negative 2 cubed is negative 8. Negative 2 quantity squared is positive 4. Negative times negative is magiging positive. And then times 2 is 2 plus 1. So, f of negative 2 is negative 1. So, ibig sabihin nun, ang value ni f of a is equal to negative 1. Okay, so this is our f of a which is equal to negative 1. Okay, the next one is the f of b. Ito yung f of b natin, si positive 1 half. Galing si 1 half sa interval ha. Okay, so parehas pa rin ng process, substitute natin doon sa original na function. So, we have 1 half cube plus 1 half squared minus 1 half plus 1. Okay, so palitan lang lahat ng variables ng x dito ng 1 half. So, we obtain 7 over 8. So, therefore, ang f of b natin is equal to 7 over 8. Okay, so 'di ba ang sabi doon sa step 3, i-compare din natin yung results na ma-obtain natin sa step 1 and step 2. So ibig sabihin nun class, doon sa step 1 din is yung nakuha natin na critical values. 'Di ba yung nakuha natin na critical values is 1/3 and negative 1. Okay, so ibig sabihin nun, isa-substitute din natin to, etong critical values natin sa original na function para ma-compare natin sila. Okay, for the f of 1/3, this is 1/3 ha. Okay, so substitute natin dito. So, we have 1/3 cube plus 1/3 squared minus 1/3 plus 1. So, i-simplify natin to. Ang makukuha natin na f of 1/3 is equal to 22 over 27. So, you can check this one. Okay, and then for the negative 1 naman, the critical value negative 1, f of negative 1, substitute natin dito sa original na function. So, we have negative 1 cube plus negative 1 squared minus 1 minus the negative of 1 plus 1. So, we have f of negative 1 is 2. And then, after that, etong dalawa na to is galing to doon sa critical values na nakuha natin sa step 1. Etong dalawa naman na ito is yun yung sa step 2 na si f of b at saka si f of a and f of b. And then, i-compare natin tong apat na to. Saan yung pinakamalaki sa kanilang tatlo? Okay, so eto, negative, ibig sabihin, eto, negative siya. Ibig sabihin, pag negative, yan yung pinaka-lowest, no? Okay, so, eto yung pinaka-smallest, rather. And then, si 7 over 8, 22 over 7, and 2 na lang yung natira. So, i-compare natin yung tatlo na yan. Saan yung pinakamalaki sa kanila? Of course, this is a fraction. 7 over 8, improper fraction sa, ibig sabihin nun, 0 point something ito. The same with 22 over 27. So, pinakamaliit is, ang pinakamalaki sa kanilang tatlo is yung whole number na 2. So, it implies that f of negative 1 is equal to 2, or 2 is the absolute maximum value, and then negative 1 is the absolute minimum value. Okay, so this is the conclusion for the step 3. Therefore, si 2 yung sinabi ko kanina na may pinakamalaking value sa apat. So, therefore, 2 is the absolute maximum value and the negative 1 is the absolute minimum value. So, ito yung gagawin ninyo. Compare ninyo yung apat. Tapos, kung may negative, automatic na siya yung pinakamaliit. Kung pinakamaliit or the absolute minimum value. And then, tingnan ninyo kung ano yung pinaka-largest value. So, eto siya. Galing siya dito.
In Theorem 8.1.7 class, that is what we call the Rolle's theorem. Let f be a function such that it is continuous on the closed interval AB, it is differentiable on the open interval AB, and the third condition is f of a equals to 0 and f of b is equal to 0, where a here is yan yung galing sa interval natin, and then yung b is also galing sa interval natin. Then there is a number c in the open interval AB such that f prime of c equals to 0. Okay. So, sa next na slide, may bibigay tayo ng example. Sa theorem 8.1.8 naman, that is what we call the mean value theorem. So, ito yung difference ng Rolle's theorem and mean value theorem. So, let f be a function such that it is continuous in the closed interval. So, the same sila ng condition. And then, sa number 2 naman, the same lang din sila. It is differentiable on the open interval AB. But, dito sa mean value theorem, then there exists a number C in the open interval AB such that f prime of C is equal to f of B minus f of A over B minus A. So, ito yung pinagkaibahan ni mean value theorem and Rolle's theorem. Kasi yung kay Rolle's theorem class is yung f prime of C niya is equals to 0. Dito kasi is may formula f of B minus f of A over B minus A.
For example, given that f of x is equal to 2x plus 3 divided by 3x minus 2, find all numbers c between 1 and 5 such that f prime of c is equal to f of 5 minus f of 1 over 5 minus 1 is equal to 1 minus 5 over 4, which is equal to negative 1. So, ibig sabihin nun, ang given natin is yung function na f of x. And then, hahanapin natin dito is lahat ng numbers c between the interval 1 and 5. So, ang given natin dito na interval is 1 and 5. It implies that our a here is equal to 1 and then b is equal to 5. Okay? And then, given na din yung f prime of c natin, that is equal to negative 1. Okay? So, before natin mahanap lahat ng numbers c, kailangan natin i-derive yung function natin. So, the derivative of this is using the quotient rule. So, ang quotient rule is the v of x times the derivative of the u of x minus v of x times the derivative of u of x over the v of x quantity squared. Sa denominator yun. Okay. So, we have 3x minus 2 times 2 that is the derivative of 2x plus 3. Then minus the first function or the high function 2x plus 3 times 3, which is yan yung derivative ni 3x minus 2. And then sa denominator is just the squared of 3x minus 2. Okay, so simplify natin to. So, we get negative 13 over 3x minus 2 quantity squared. Okay, so since given na si f prime of c, that is equal to negative 1, ibig sabihin nun, yung nakuha natin na derivative niya is, yung variable x dito is, i-replace lang natin yan ng variable c. Okay, so, eto, replace variable x by c, that is equal to negative 1. So, ibig sabihin nun, si f of x dito kanina, yung dito, eto siya is, ipapalitan natin yan ng negative 1. So, we have negative 1 is equal to negative 13 over 3c minus 2 quantity squared. Etong c na to is, kanina is, that is the variable x. So, solving for the value of c, so cross multiply natin. So, we have negative 1 times, di ba, 3c minus 2 quantity squared is the negative 1. So, since may negative dito, so negative divided by negative is magiging positive na siya. So, we have 3c minus 2 quantity squared is equal to 13. So, squaring it both sides. So, we have 3c minus 2 is equal to positive and negative square root of 13. Okay? So, solving for the value of c. So, ito is dalawa yung value ng c natin dito since plus and minus ito. So, we have c is equal to plus and minus square root of 13 plus 2. Transpose natin si 2 dito para ang matira na lang sa left side is the variable c. And then, divide it both just by 3. So, paghiwalayin natin to, the positive 1 is the square root of 13 plus 2 over 3. And then the negative 1 is the negative 13 plus 2 over 3. So, since ang interval natin is from 1 to 5, so ibig sabihin ang i-consider lang natin na values ng c is yung sa positive. So, ibig sabihin rejected na yung sa negative na value ng c. Kasi, between 1 and 5 man, ibig sabihin yung mga numbers lang na between 1 and 5. So, kasama doon si positive square root of 13 plus 2 over 3. So, therefore, this is the value of c.
The next topic in the applications and derivatives is the increasing or decreasing functions in the first derivative. Kanina kasi is yung maximum and minimum values of a function. The first definition here, class, is a function f defined on an interval is said to be strictly increasing on that interval if and only if f of x sub 1 is less than, okay, take note of the function f of x sub 2 whenever x sub 1 is less than x sub 2, where x sub 1 and x sub 2 are any numbers in the interval. And a function f defined on an interval is said to be strictly decreasing naman on that interval if and only if f of x sub 1 is greater than, kabaliktaran kanina. Kasi kung strictly increasing yung function natin na f of x sub 1 is less than siya kay f of x sub 2. Kung strictly decreasing naman, class, on that given interval, if and only if yung function natin na f of x sub 1 is greater than siya kay f of x sub 2. Whenever x sub 1 is greater than x sub 2, where x sub 1 and x sub 2 are any numbers in the interval. If a function is either increasing or decreasing on an interval, then it is said to be monotonic. Okay, so either increasing or decreasing on that given interval, class, we can say that the function is monotonic on that interval. The first theorem is, in this topic is this theorem 8.2.2 sa increasing or decreasing in the first derivative. Suppose the function f is continuous on an open interval I in the f prime is not equal to 0 on the open interval I, then f prime is either positive on all of the given interval I or negative on all of the interval I. So which means if yung function natin is continuous siya, class, sa open interval na yun, and then yung f prime natin or first derivative is not equal to 0, then f prime is either positive siya doon sa interval natin or pwede siyang maging negative doon sa interval natin. Let the function f be continuous rather on the closed interval and differentiable on the open interval AB. Then, if f prime of x sub o, take note, the first derivative is greater than 0 daw siya, which means positive. For all x in AB, then f is increasing on the closed interval AB. So, pag nakita ninyo na yung first derivative ninyo, class, is positive or greater than 0, which means yung function na yun is increasing siya sa closed interval na AB. And then, if f prime of x is less than, take note, less than 0 for all x in AB, then f is decreasing. Okay, so if yung first derivative naman natin is negative or less than 0 siya, then we can say that the function f is decreasing on that closed interval AB. So here is another theorem. The first derivative test for relative extrema. So when we say relative extrema, that is the relative maximum and relative minimum. The same lang din doon sa first discussion natin sa maximum or minimum values of function, relative extremum or relative extrema. Let the function f be continuous at all points of the open interval AB containing the number x sub o rather, and suppose that f prime or the first derivative, kasi yung pinag-uusapan dito is the first derivative test, exists at each point of AB except possibly at x sub o. Okay, so take note, if f is increasing, okay, if f is increasing, which means the first derivative is greater than 0. Na-mention na natin to kanina sa previous slide, yung previous theorem. On some open interval to the left, okay, some open interval to the left of x sub o, which means from negative infinity, with x sub o as endpoint of this interval, and if f is decreasing naman, where this is f prime ha, f prime of x sub o is less than 0, which means less than 0, ibig sabihin nun negative, no? On some open interval to the right, okay, take note, to the right of x sub o, with x sub o as endpoint, then f has a relative maximum value at x sub o. Okay, so masasabi din natin, class, na yung function natin has a relative maximum value at the point x sub o if yung first derivative natin is increasing siya on some open interval to the left of x sub o, tapos decreasing siya on some open interval to the right of x sub o. So take note that ha, relative maximum value if increasing scan yan papunta sa left, and then decreasing scan yan on some open interval to the right. Okay. If f is decreasing naman, f prime of x sub o is less than 0. Baliktad. Kanina kasi nauna dito is increasing, no? So here, if f is decreasing, f prime of x sub o, f prime of x is less than 0, basta decreasing na si first derivative yun na, less than 0 talaga nan. Ibig sabihin na mga negative numbers. On some open interval to the left, baliktad ha, decreasing siya to the left, okay? And then, if f is increasing, where f prime of x, this is f prime of x greater than 0 on some open interval to the right. Okay, kanina, baliktad kasi increasing siya to the left, tapos decreasing siya to the right. So, sa pangalawa class, relative maximum yun. Kung relative minimum naman class, decreasing siya to the left, and then increasing siya to the right. So, then f has a relative maximum value at x sub o. So, summarize natin. Yung first, let's say, may interval tayo dito. Yan. And then, masasabi natin na may relative maximum daw siya if yung first derivative natin is greater than 0, which means increasing siya to the left. Ibig sabihin, positive siya dito. Yan man yung papunta sa left, di ba? That is approaches to the negative infinity. And then, decreasing daw siya to the right, which means negative siya dito. So, ang endpoint natin dito, class, let's say 0 yung endpoint natin. Okay. So, ang ibig sabihin lang nito, if this is our endpoint, x sub o, that is equals to 0, approaches to the left is increasing, tapos approaches to the right is decreasing. Okay. And then, sa pangalawa naman class, pwede natin siyang ma-summarize as, okay, let's say nandito si 0 sa gitna nila. Kasi ang sabi naman dito, with x sub o as endpoint of this interval. So, we let x sub o equals to 0. So, masasabi natin na yung function natin has relative minimum if decreasing siya on some open interval to the left. So, which means negative siya dito sa left side. And then, increasing siya on some open interval to the right. So, positive siya dito sa right side. So, given ni relative max ako, relative mean. So, naino ka sa example tayo class, nag-explain nun na yan, kagamit yun na yan. The next topic dun sa increasing and decreasing of and the first derivative test is the concavity and points of inflection. So, magagamit din natin to dito sa following example. So, no? So, example si increasing ago si kuan. So, dito may di-discuss ka na saya ki concavity and points of inflection na kasamarise kanyan busa sa tima na example. The graph of a function f is said to be concave upward. Concave upward, take note, on a given interval I, if at each point of I, the graph of f always remains above. Pag concave upward siya class, it remains above yung graph ng function natin na f, above the line tangent to the curve at this point. The graph of f is said to be concave downward naman on a given interval I, if at each point of I, the graph of f always remains below. Basta concave downward, yung graph ng function natin always remains below the line tangent to the curve at this point. So, madali lang. Concave upward, which means remains above. And then concave downward naman, yung graph ng function natin is always remains below the line tangent to the curve at this point. Okay, so natakol na natin kanina yung first derivative test. Meron din tayong second derivative test for concavity. Si first derivative test class is magagamit natin yun sa pag-determine natin if saan yung function natin is saan ba siya increasing or decreasing, sa anong interval ba siya may relative max at saka may relative mean. Sa second derivative test naman class is magagamit natin to for concavity, test for concavity, and yung point of inflection. Let f be a function such that f double prime, kasi second derivative naman. I already discussed derivatives of higher orders, which means may idea na kayo kung paano makuha yung second derivative ng given na function. Okay, so let f be a function such that the second derivative of f of x exists for every x in some open interval I if f double prime of x, or the second derivative of x, is greater than 0 for all x on the interval I, then the graph of f is concave upward on the given interval. So if yung second derivative natin class is greater than 0, which means positive siya, then yung graph natin is concave upward. Ibig sabihin, always remains above the line tangent to the curve at this point. And then if yung second derivative naman natin is less than 0, then the graph of f is concave downwards. So madali lang. Pag greater than, yung second derivative ha, take note, second derivative yung titingnan natin. If greater than 0 siya, concave upward. If less than 0 yung second derivative natin, which means concave downward yung graph niya. Second derivative test for relative extrema. Okay, so suppose that f double prime of x exists on the interval I, and suppose x of O is an element in the given interval, is a critical value of f. Okay, if f double prime of x sub O is greater than 0 for all x, then x sub O corresponds to a relative minimum value of f. And then if yung second derivative naman natin class is less than 0 siya, then x sub O corresponds to a relative maximum values, which means the opposite, no? Kung maximum, less than. Kung minimum, greater than. Yan yung sa second derivative test for relative extrema. Okay, take note, if f double prime of x is equal to 0, then the above second derivative test for relative extrema does not apply. Okay, so take note that ha, if yung second derivative natin is equals to 0, then this test does not apply for relative extrema. A point x sub O, f of x sub O, is a point of inflection of the graph of the function if the graph has a tangent line there. If there exists an open interval I containing x sub O such that if x is in the interval, then either, okay, f prime of x sub O is less than 0 if x is less than or equal to x sub O. And f double prime of x naman is greater than 0 siya if x is greater than x sub O. Or f double prime of x is greater than 0 if x is less than or equal to x sub O, and if the f double prime of x naman is less than 0 if x is greater than x sub O. If the function is differentiable on some open interval containing x sub O, and if the point x sub O, f of x sub O, is a point of inflection of the graph of the second derivative of f of x sub O exists, which means f double prime of x sub O is equal to 0 rather. So take note class, the converse of the theorem above is not true. That is, if f double prime of x sub O equals to 0, then it is not always true that that x sub O and f of x sub O is a point of inflection of the graph. And then from the definition and theorem above, it follows that a point x sub O or f of x sub O is a point of inflection if f double prime of x sub O equals to 0 or f double prime of x sub O does not exist, and the graph of f is concave upward on one side and the concave downward on the other.
Okay, for example, given the function f, discuss its relative maximum and relative minimum points, the intervals where it is increasing or decreasing, the intervals of concavity, and the points of inflection, and then after that, construct a sketch-up graph of the given function. So, sa example number 1, ang given na function is f of x is equal to x cubed minus 3 over 2 quantity squared or 3 over 2 x squared. Okay. So, ang hahanapin daw natin dito sa given na to is i-determine natin kung ano yung relative maximum and relative minimum points niya, and then yung intervals na kung saan siya increasing or decreasing, and then yung intervals ng concavity niya, and then the points of inflection. And then after that, mag-sketch tayo ng graph ng given na function na to. The first step, class, to find those relative maximum and relative minimum points, the interval where it is increasing or decreasing in the intervals of concavity and the points of inflection is, ang first step is get the first derivative of this. Okay, so kaya kailangan natin yung first derivative niya para malaman natin kung ano yung critical values niya. Okay, and then after that, the second step is get the second derivative of the given function para makuha din natin yung points of inflection. Okay, so f of x is equal to x cubed minus 3 over 2x squared yung given natin na function. So ang first derivative niya is magiging 3x squared minus 3x. Okay, so 3x squared minus 3x, because if i-bring down natin si 2 dito, di ba makakancel out na yan, so we left with 3x na lang. In here is magiging 3x squared. So ito yung derivative niya, katulad ng solution natin kanina, i-equate natin siya sa 0. Okay, so 3x squared minus 3x equate to 0. And then, i-factor natin to kasi kailangan natin dito is yung values ni x. Kasi yun yung magiging critical values natin. Okay, so 3x, i-factor out natin because 3x is their greatest common factor between first term and the second term. Okay, so 3x, we left with x na lang sa first term. Then sa second term is 1 na lang. Okay, so equate natin siya 0. So 3x equate to 0. So solving for the value of x, so we have x is equal to 0. And then x minus 1 naman, equate natin yan sa 0. Transpose natin si negative 1, magiging positive 1. So that's why ang values ng x natin dito is 0 and 1. So it implies that ito yung magiging critical values natin. CV stands for critical values. Si critical points is etong nakuha natin na critical values is substitute lang natin sa original na function. So, kung ano yung makuha natin na value doon, yun yung ilalagay natin dito sa y coordinate. The same with 1 na critical value. Substitute natin dito, then may makukuha tayo na f of x that is equal to y, is yun din yung ilalagay natin dito. Okay, then let's proceed to the second derivative. Ang second derivative nito is 3 times 2 is magiging 6. And then 2 minus 1 is 1 na lang. So we have 6x minus, sa second term, ang derivative ni 3x is 3. So ito yung second derivative niya. The same process pa rin. Sa pagkuha ng critical values, equate natin sa 0 sa second derivative. And then, we have 6x minus 3 is equal to 0. So, solving for the value of x, just transpose the negative 3. So, magiging positive 3. So, since si x yung target natin, divided both sides by 6. So, we have x is equal to 1/2 because 3 over 6 is divisible by 2. So, pwede natin siyang ma-reduce in lowest term as 1/2. Okay? So, yung nakuha natin na value dito, yung nakuha natin na x dito sa second derivative is yun yung tinatawag natin na point of inflection. So, remember, si critical values and critical points is kay first derivative yung basihan niya, and then sa second derivative naman is yung points of inflection. And then after that, after ninyong makuha si first derivative para kay critical values and then sa second derivative para doon kay points of inflection, is magkukonstruct tayo ng sign chart. Okay, so ito yung tinatawag na sign chart. Okay, so inilalagay ninyo dun sa sign chart is the interval and then the test points, the function f of x, yung given natin na function na f of x, pero hindi ko na sinulat dito yung equation ha. And then the sign of the first derivative na function, and then the sign of the function, the second derivative na function. So, ibig sabihin nun, yung test points natin na yung gagamitin natin dito para malaman natin kung ano yung ilalagay natin dito na mga signs. Okay, so ano yung magiging basis natin sa interval? So, Yung nakuha natin na critical values at saka si point of inflection is iipunin natin yan, and then after that, i-arrange natin sa number line. Okay, so di ba si 0 and 1, yan yung CV natin. Okay, so this is our critical values. And then si 1/2 naman is, that is our point of inflection. So, si critical values, 0 and 1, and then si 1/2 is the points of inflection. So, i-arrange natin yan sa real number line. So, di ba sa real number line, si 0 yung nasa gitna. Since lahat yan positive, ibig sabihin dito natin yan ilalagay sa right side. Okay, so si 1, di ba dito yan? After the 0, and then si 1/2 naman is nasa gitna ni 0 and 1. So, ibig sabihin, nagiyay kapag katutunog-tunog yan. Okay, so ginan mo way kapag rin siya nyo rin saya sa interval. Okay, so mag-start kayo kay negative infinity and then mag-stop kayo kay positive infinity. Okay, so ganito yan. So since ang nauna dito sa real number line natin is si 0, ibig sabihin yan yung ipapartner natin dito kay negative infinity. So we have negative infinity, 0, and then ini-next natin dito is 0 kasi di ba 0 yung 0 tayo nag-stop, and then since 0 yung nilagay natin dito, ilalagay din natin dito si 0, and then di ba yung next kay 0 is si 1/2, ibig sabihin ipa-partner natin dito is si 1/2, and then since nag-stop tayo kay 1/2, 1/2 din yung ilalagay natin dito, and then nag-stop tayo kay 1/2, 1/2 na naman tayo mag-start, then di ba ang next kay 1/2 is si 1, so yan yung ipa-partner natin dito kay 1. And then, since nag-stop tayo kay 1, 1 na naman tayo mag-start, and then mag-start na naman tayo dito kay 1, and then ipa-partner natin dito is si positive infinity. So, naglagay na tayo dito ng positive infinity kay 1 because tatlo lang kasi, or nag-end man tayo kay 1. Kung may kasunod pa yan dito, lalagay pa natin. Say for instance, may 3 dito. So, 1, 3, tapos 3, and then saka tayo maglagay ng 3 to positive infinity. Okay, so ganun yung pag-arrange ng sa interval. And then after that, sa test points, kukuha lang kayo ng mga numbers na pwedeng kailangan nandyan lang sa interval na yan. Okay, so di ba negative 1 is between, nasa loob lang siya ng interval na negative infinity to 0. Then kung number lang yan, bring down nyo lang. And then 0 to 1/2, ano yung numbers na nasa gitna nila? So ang pinili ko is 1/3. So pwedeng ito palitan niyo yung negative 2, negative 3, or negative 0.5. So, depende na sa inyo. And then, 1/2. Tapos, ang between sa number, sa interval ni 1/2 and 1 is 2/3. Then, we have 1, 1, and then 1. Between sa kanya, 1 to positive infinity is 2 yung pinili ko. So, pwede ding 3, pwedeng 4, pwedeng 5, pwedeng 6. Pero, hindi pwedeng maging 0. Kasi 0 is not between 1, not between in the given interval 1 to positive infinity. Kailangan yung nasa loob lang talaga ng interval. Okay, so, yan yung mga test points natin. Okay, and then after that, after ninyong makakuha ng makadetermine ng test points, lahat ng test points natin, yan, kay negative 1, 0, 1/3, 1/2, 2/3, 1 and 2 is isa-substitute natin yan doon sa original na function. Okay, so si negative 1 is substitute kay original na function. Diba ang given natin na original na function is x cube minus 3/2x quantity squared. So, ibig sabihin si negative 1, i-replace niyo sa mga variable x na yan. So, ang na-obtain natin is si 5/2. So, kayo na yung bahalang mag-check. And then, pag i-replace natin to ng 0, di ba magiging 0 siya. Pag i-replace natin to ng 1/3, ang result is negative 21/162. And then, if we replace x here by 1/2, we obtain negative 1/4. Okay, take note, kay original function tayo sa substitute, ang gagamitin is si test points. Okay, the same with 2/3, so we obtain negative 10/27, and then kung 1 naman yung i-replace natin dito, magiging negative 1/2. Then kung 2 naman, we have 2. Parehas sila. Okay, so hindi ibig sabihin na 2 ito, 2 2 din yung ilalagay nyo dito. So, nag-coincide lang talaga, nagkataon lang na 2 yung naging result niya sa pag-substitute natin dito ng 2. And then after that, si test points pa rin. Okay, so pinaka-importante is si test points at saka si interval. Okay, so si test points, gagamitin na naman natin kay f prime of x. Ibig sabihin, yung first derivative na nakuha natin. Di ba yung nakuha natin na first derivative class? Okay, so ang f prime of x natin is equal to 3x squared minus ilan ba yun? 3x. Okay. So, ibig sabihin nun, si negative 1, isa-substitute natin dito sa function na f prime of x. Ibig sabihin, kay first derivative na. So, after ninyong mag-substitute, ang ilalagay nyo lang dito is yung sign. Kung ang result niya is positive, positive yung ilalagay. Okay. So, if we replace 0 here, diba magiging 0 na yan? So, 0 yung ilalagay nyo dito. Kung 0 yung sagot, 0 yung ilalagay. Kung number, ang ilalagay nyo lang dito is yung sign. Okay. If we replace 1/3 by 3x squared minus 3x is negative yung magiging result niya. The same also with 1/2. Substitute natin kay first derivative. Negative din yung result. Si 2/3. Tapos, si 1 is 0 and then si 2 is positive. Okay. Take note, sign. Kaya nilagyan ng sign of first derivative kasi sign lang yung ilalagay dito except kay 0. Pag 0, 0 talagang ilalagay ninyo. The same also with the second derivative. Yung mga test points, isa-substitute natin kay second derivative. Okay, so may na-obtain tayo na second derivative. Ang second derivative na nakuha natin is si 6x minus 3. So, if we replace negative 1 to 6x minus 3 is magiging negative. Okay, the same with 0, negative din. Si 1/3, negative. Si 1/2 is 0. Si 2/3 is positive. Si 1 is positive. And 2n is positive. So, take note, lahat yan sign lang. Okay, so kaya natin kailangan si sign chart para ma-determine natin kung saan increasing or decreasing yung function natin, sa ano yung interval na meron siyang relative maximum value, and then saan siya may relative minimum value na interval. At the same time, saan siya concave upward and concave downward. Okay, so si increasing, si decreasing, si relative maximum and relative minimum value class is doon tayo magbabase kay first derivative. So, ibig sabihin ang basis natin is yung sign ni first derivative. Okay. So, increasing, malalaman natin yan class if, okay, sa first derivative, sign ng first derivative, saan siya nag-positive. Okay, so di ba nag-positive siya kay negative infinity to 0. So, ibig sabihin, isa sa mga interval na yon is si negative infinity to 0. Okay, saan siya nag-positive ha? Kasi increasing, ibig sabihin pataas. Saan na naman siya nag-positive? Diba kay 1 to positive infinity? So, ibig sabihin nun, ang ilalagay natin dito na interval, corresponding interval is yung interval sa taas. Dito tayo magbe-base kay sign ng first derivative. Okay, positive, yun yung ilalagay natin kay increasing. Then, positive siya dito, yun yung ilalagay natin kay increasing. And then, if f is decreasing naman at the interval 0 to 1. Bakit natin sinabi na 0 to 1? When we say decreasing, pababa yan. So, ibig sabihin, titingnan natin sa sign ng first derivative natin kung saan siya nag-negative. So, di ba dito siya nag-negative start kay 0 to 1/2, tapos 1/2, tapos 1/2 to 1. Okay, so if kukunin natin yung union nito, that is from 0 up to 1. Kasi diba si 1/2 is nasa gitna lang man or between kay 0 at 1. So that's why ang nilagay lang natin dito na interval is 0 to 1. 0 to 1 kasi si 1/2 andyan lang sa gitna nila. Okay, next is f has relative minimum value. Okay, so malalaman natin yung minimum value na yan. Dito pa rin tayo kay first derivative titingin. Okay, relative minimum value class, tingnan natin kung saan siya nag-0. Okay, so di ba nag-0 dito? Okay, tingnan natin kung sa left side niya is positive ba, tapos yung sa left side niya, sa right side niya is negative. So, ibig sabihin nun, nag-0 dito, tapos yung nasa left side niya is positive, yung nasa right side niya is negative. Ibig sabihin yung interval na yan is yan yung magiging relative maximum value. Okay, take note, tingnan ninyo kung saan may 0. Okay, so 0, and then tingnan ninyo yung mga sign. Kung nag-positive siya sa left side, tapos nag-negative siya sa right side, ibig sabihin nun, yung points sa taas ni 0, si test point at saka si f of x, yun yung magiging relative maximum value natin. Okay, the same also with the relative minimum value. Kay first derivative pa rin tayo na sign. So, diba nag-0 dito? Okay, kay relative minimum value naman baliktad. Positive siya sa right, tapos negative siya sa left. Okay, so tingnan natin kung ano yung points ng nasa taas ni 0. So, we have 1 and negative 1 half. So, yan yung relative minimum value natin. Okay, so we have 1 and negative 1 half. Okay, f is concave upward at the interval 1 half and positive infinity. Okay, ang basis naman natin kay concave upward and concave downward is the second derivative. Ibig sabihin yung sign ni second derivative. Okay, concave upward, ibig sabihin pataas yan. Upward, ibig sabihin positive. So, saan siya nag-positive? Nag-start kay 1 half. Okay, positive dito. Nag-end siya kay positive infinity. So, ibig sabihin nun, f is concave upward at the interval 1 half and positive infinity. Okay, concave downward, ibig sabihin pababa, negative. So, nag-start siya kay negative infinity. Nag-stop siya kay 1 half. Okay, so we have negative infinity to 1 half. So, f is concave downward at the interval negative infinity and 1 half. And then the last one is, okay, so na-determine na natin lahat. Okay, kompleto na. Ang last na lang is the graph. Okay, so ang ilalagay lang natin class sa graph is yung kung ano yung interval or ano yung points, relative maximum value or relative maximum points and relative minimum value. Yan lang yung ipa-plot natin dito. And then, eto yung nasa gitna nila. Okay, so balikan natin yung graph natin. So, di ba? Ito yung relative maximum and this one is the relative minimum value. Okay. So, pwedeng ito, di ba si 1 half yung nasa gitnaan ng real number line? Okay, sa tatlo na yan, si 1 half yung nasa gitna. Ibig sabihin, tingnan natin kung ano yung points na nasa baba ni 1 half. So, we have 1 half and negative 1/4. So, isasali natin to sa graph natin. Okay, so ito yung relative maximum natin and then ito yung relative minimum, di ba? Concave upward siya from negative infinity to 0 and then concave downward rather, and then concave upward siya from 1 half. Okay, mag-start kay 1 half to positive infinity. Okay, so ito yung graph natin.
So next example, parehas lang dun sa number 1, the same pa rin yung process. Given the function f, x to the 4 minus x, 8x cubed plus 18x squared minus 27, discuss its relative maximum and minimum points, the intervals where it is increasing or decreasing, the intervals of concavity, and the points of inflection. Construct a sketch of the graph of the function. So, di ba, ang first na ginawa natin doon sa first example is, kinuha natin yung first derivative ng given natin ng function. So, the first derivative of this given function is 4x cubed minus 24 kasi 8 times 3, no? 24x squared plus 18 times 2 is 36x, and then derivative of 27 is 0 na siya. So, hindi ko na nilagay dito si 0. So, setting this to 0, etong nakuha natin na first derivative, we have 4x cubed minus 24x squared plus 36x equals to, okay, factor out natin si 4 because 4 is their greatest common factor. So, we have 4. And then also yung x is their greatest common factor also. So, we have 4x times. So, sa first term, we left with x x squared na lang. Then sa second term, we left with 6x. Then sa last term is 9. Or we can express this one as 4x times x minus 3 times x minus 3, no? Kasi ang factors nito is x minus 3 times x minus 3. Or, pwede din siyang ma-express as 4x times x minus 3 quantity squared. Kasi di ba dalawa man yung factor natin na x minus 3 equals to 0. So, hence, kaya natin to inequate into 0 para ma-solve natin yung value ng x kasi yun yung magiging critical values natin. Okay, hence, solving for the value of x here, 4x, equate natin sa 0, di ba magiging 4x equals to 0. So, divided both sides by 4, we get x equals to 0, right? Kasi 4 divided by 0 divided by 4, rather, dividing it both sides by 4, sorry. And then, 0 divided by 4 is 0 pa rin. So, x minus 3 quantity squared, ang makukuha natin na value ni x is 3. Kasi di ba ang mayroon dyan is x minus 3. Okay. Quantity squared, no? Equals to 0. Okay, so this is 2. So, squaring it both sides. Squaring natin yan both sides. So, makakancel out yung exponent na to at saka yung index natin. So, we left with x minus 3 na lang. And then, square root of 0 is 0 pa rin. So, that's why, ang makukuha natin na pangalawang value ng x is x equals to 3. So, it follows that x equals to 0 and x equals to 3 are the critical values of f. So, substituting these critical values to the original equation, dito natin siya isa-substitute. We get f of 0 is negative 27 and f of 3 is equals to 0. So, thus, the critical points are 0 and negative 27, tapos 3 and 0. So, eto class, nakuha ito kasi yung nakuha natin na critical values, sinubstitute natin sa original function, then may nakuha tayo na f of x. And then, the second step is to get the point of inflection. So, take note, si first derivative, kakuha niyo ron na si critical values ago si critical points. Kay second derivative mo buo na yung kakuha niyo ron na si point of inflection. To get the point of inflection, we need to find the second derivative of the given function, that is, ito yung function natin. Then the second derivative of this function, para makuha natin yung second derivative niya, just simply use the first derivative. Then, i-derive nyo lang yung nakuha ninyo na first derivative. So, f prime of x, f double prime of x rather is equal to 12x squared kasi 4 times 3 is 12. And then, 3 minus 1 is 2. And then, 24 times 2 is 48. And then, 2 minus 1 yung exponent, magiging 1 na lang. And then, derivative of 36 is 36. So, this is the second derivative. So, setting this one to 0 para the same process pa rin sa first step para makuha natin yung value ni x. Hence, ang factors nito is 12 times x minus 3 and x minus 1. It follows that x equating both factors into 0. So, we get x equals to 3 and x equals to 1. So, yan yung magiging points of inflection natin. The third step is construct a table of sign. So, paano ba natin makuha or ma-obtain yung ilalagay natin dito na intervals? Okay, ang gagawin nyo lang class, arin siya niyo sumiyakuan yung table of what I mean is interval, critical values ako si point of inflection, di ba? Okay, dito may basis yun. So, di ba ayam yakuha no critical values na 0 ago 3. Tapos, ang nakuha din natin na points of inflection is 1 and 3, no? Okay. So, yan. I-combine natin yan sa number line. I-arrange natin ba? Okay, di ba si 0 is always in nasa gitna? Okay, so okay na si 0. Si 1 is to the right of 0. So, nandito si 1. And then, next kay 1 is si 2. Tapos, next kay 2 is si 3. So, nandito din si 3. So, 0, 1, and 3. So, which means, ang i-consider natin na values class ng x is from negative infinity to positive infinity. So, which means, sa pag-construct ng intervals is kailangan always kayo mag-start kay negative infinity. Okay, so ano yung number na nauna dito nakasali sa critical value at sa point of inflection, di ba si 0. So which means, ang unang interval nilalagay natin dito is from negative infinity to 0. So katest kanyan. And then, since nag-stop kayo kay 0 dito, ilalagay nyo dito na next sa interval ninyo is 0 alone lang. Kasi etong 0 na yan, class, is kasali siya sa critical value. Okay. Gayang mga numbers saya na sibunan kinuha kay critical value guki, point of inflection. Do not worry. Wala kayong isipin na ibang number, kundi dito lang kay CV at saka kay point of inflection. Okay, since nag-stop tayo dito kay 0, mag-start na naman ulit tayo kay 0. So, ano yung next kay 0 na number na kasali kay CV at point of inflection? Diba si 1? So, that's why 1 yung nilagay dito. 0 and 1. Since nag-stop tayo kay 1, 1 din yung ilalagay nyo dito. Okay. And then, since nag-stop tayo dito kay 1, mag-start na naman tayo kay 1. So, ano yung number na next kay 1 nakasali kay CV and point of inflection? Di ba si 3? Okay. Hindi si 2 kasi hindi man siya kasali kay critical value at saka kay point of inflection. So, 1 and 3. Tapos, next dito is si 3. Kumbaga na, parang chain buhay Wala ka nung stop, gito manitigo nyo na next na. So, pag-stopan nyo man, ang gito pa ni pagpunan nyo. Okay? Then, since nag-stop tayo kay 3, yun din yung unang ilalagay natin dito sa interval natin. And then, since may pasad so critical value tano gusto point of inflection, na aya pinakalas ko intervals tano class na so positive infinity. Since nag-start tayo kay negative infinity, kakailangan tano kasi i-consider lang a value sa x, possible values of x from negative infinity to positive infinity para malaman natin kung saan increasing or decreasing yung function natin, ano yung relative maximum or minimum point, tapos saan siya concave upward or concave downward. So, ang mga test points class, dito lang yan kinuha sa mga intervals natin. So, since negative 1, siya yung pinakamalapit kay negative infinity to 0, pwede ding negative 2 yung ilagay nyo dito. Okay, si 0, bring down nyo lang. 0, ang number between 0 to 1 is 1 half. Hindi pwedeng 1, hindi pwedeng 2, hindi pwedeng negative 1 ha, kasi wala yun sa gitna ni 0 and 1. Okay, bring down 1. 1, 3. Ang number na between 1, 3 is 2. Pwede din kahit anong number, basta nasa gitna lang ng interval na yun. Okay. Just bring down 3. Tapos, ang number na mas pinakamalapit kay 3 is si 4. Pwede din 5, 6, 7. It's up to you. As long as nandun sa interval natin. Nag-satisfy siya. Okay. So, para malaman niyo yung value ni f of x, diba ang given natin is x to the power of 4. Okay. So, gaya class f of x na gaya so given yung original function. So, gi-choose yung sa test points na ipag-substitute yung rumbo para makuha nyo sa value niyan. So, if we substitute to the given value, to the given equation, x to the 4, and then may kadugtong pa siya ha. Okay. So, i-substitute natin yung negative 1 sa original function natin. We get 0, the same with 0, ang nakuha natin is negative 27. Tapos, si 1 half, we get negative 375/16. Kung 1 naman yung isa-substitute natin kay original function, we get negative 16. You can check, class, if tama ba yung nakuha natin na value ng f of x. The same with 3 and then 4 na test point. And then, first derivative class, di ba, kinuha natin yung first derivative ng function natin at saka yung second derivative. So, dito, sasali din natin siya sa table sign natin or sign chart. But, ang ilalagay nyo lang dito is not the value but the sign only. Okay. If i-substitute natin si negative 1 kay first derivative na function natin, yung nakuha natin na first derivative ng function, i-substitute natin si negative 1 yung test points, ha? Okay, giya pa rin ni basis yo. Tawan sa kapapasad yung tamang ki second derivative na ay kakwatan na result na negative kon. So, ayun yung sibutego na. So, sign na negative. Tapos, si 0 na i-substitute ki first derivative of function na kakwatan na 0. The same with 1 half na positive. Si 1 na positive, 0 ago, positive. Si test point po talaga pag-substitute yung first derivative na pasado tukman na second derivative man na lagi ayan nyo po sa teguon na. So, sign yan. Okay. So, here is the summary. Ang critical values natin is 0 and 3. Critical points are 0, negative 27, and 3, 0. Tapos, points of inflection are 1, 3. F is increasing at the intervals 0 to 3, and then 3 to the positive infinity. So, the union of this interval is 0 to positive. Kung titingnan natin doon sa graph natin class as a sign chart, is makikita ninyo, tingnan ninyo yung sa first derivative. First derivative, malalaman ninyo na increasing siya if saan nag-positive siya. Sa right at saka sa, i-consider niyo yung definition ng yung sa increasing or decreasing and the first derivative test. Tapos, f is decreasing naman at the interval negative infinity and 0. Parehas lang to class, mag-base kayo doon sa previous example natin. It has relative maximum, it has no, okay, it has no relative maximum value. F has a relative minimum value at 0 to negative 27. And then F is concave upward from negative infinity to 1 and 3 to positive infinity. F is concave downward naman at the point 1/3. 1 and 3 rather. So, ito yung relative max. Since wala siyang relative maximum, relative minimum lang tayo meron. So, ang relative minimum natin is 0 and negative 27. So, nandito sa point na to. So, since concave upward daw siya from negative infinity, di ba? Ito yung negative infinity natin. Papunta kay 1. So, pataas siya, papunta dito kay 1. Okay, kung galing tayo dito kay relative mean, okay, paakyat na siya doon. And then, paakyat din siya from 3 to positive infinity. And then, concave downward naman kay point na 1 and 3. So, ito yung point natin na 1, 3. Pababa siya dito. Pababa siya dito, di ba? Okay, so concave downward.